So EMA has filed for a patent for our plasma simulation technology. So when people do simulation of plasmas, the types of plasmas are for various types of RF plasma interactions. For example, in plasma-enhanced semiconductor manufacturing technologies, they use a technique called particle in cell to model electrons, ions, and other carriers, and also solve the electromagnetic equations as well as the Navier-Stokes equations. And in our technology, the challenge that we overcome is that particle in cell requires very small time steps to resolve the motion of those macro particles. And then the plasma itself has Debye length and sheaths that are very small that require a small computational cell size. So when you combine the requirement for a small computational time step with a small spatial time step, it becomes computationally impractical to model these problems. Our innovation provides methods to use a larger time step across multiple RF cycles. It also has innovations that allow us to use a larger computational spatial time step. And that allows us to have fewer cells that we're modeling. And it takes an impossible problem and makes it practical to solve. The impact of having this new technology is that engineers will be able to use the simulation tool to solve industrially relevant problems. So for example, if you're solving a plasma-enhanced manufacturing process, such as plasma-enhanced chemical vapor deposition or something related to that, you can reach the 3D problem now. And we believe that 3D is required for modeling all the processes that are happening in these chambers so that you can understand the non-uniformities. And ultimately what people want to know is the angular distribution, the energy distribution of ions that get through the sheath and make it to the chip. And so now we're going to be able to accurately solve that for your real geometry, real flows, and handle all those processes so we can predict what actually happens during the plasmas used in the manufacturing process. So you can optimize your techniques so that you can improve your yield and increase the performance of your manufacturing. So what comes next for EMA is we will continue to refine this technology and make it easier for users to use it in the simulation technology, as well as automate the problem setup so that you will be able to more quickly run through variations of parameters and automatically set those simulations up, run them on HPC GPU computing, and get the results and analyze those variations much faster. In the future, this is harmonious with the EMA 3D Connect products, which will allow for AI and machine learning to help automate some of the processes for setting up these models, as well as provide quick, real-time feedback to engineers on their path to running the full wave simulation to get their final results.